Okay, welcome back everyone. This is a Calculus 2. In this video, we are going to talk about 3.4 partial fractions. So I've been introducing a variety of integral techniques. The first thing you need to check what kinds of function you are dealing with. We are, we know, many different type of functions since pre-calculus, calculus 1, and calculus 2. So especially when you're dealing with partial fractions, how would you be able to take the integral? That's the main question here in 3.4. So let me show you that idea. We always know the integral symbol f of x dx. So today I'm going to introduce, if you have a partial fraction, right? Are we able to take the integral? Yes, and here is the steps that I want to show you today. So a little bit of review from pre-calculus. Many people may be forgetting what the partial fraction means. So if you remember, partial fractions are the fractions that are formed when a complex rational expression is split into two or more simpler fractions. So what I'm saying is, let's say I have a fraction x over y. You can have a couple partial fraction to get x over y. It could be, a over b, c over d, or you can have a more than 2 or 3. It could be, a lot. So let me see, we have a 3, like g. So these are little simple fraction, and then you're adding them, those are 2 or more simpler fraction. They are partial fractions of x over y. Does it make sense? So you have like a 1 over 2, 1 over 3. So if you're adding them, so first you need to find out the common denominator, multiply 3 to the first fraction, multiply 2 to the second fraction. So it is going to be 3 over 6 and 2 over 6. So we know that 1 over 2 plus 1 over 3 is a 5 over 6. Am I correct? So I can say 1 over 2 and 1 over 3 are partial fractions of 5 over 6. So we're going to find out the partial fraction when you have a complicated function. And then, once you take the integral of the partial fraction so that you can find out the answer in an easier way. So to find out the partial fraction, we call the process is a decomposing process, decomposing work, or the decomposing process. So by utilizing decomposing fractions, you can find out the partial fractions of x over y. Does it make sense? So here is the idea. I want to take the integral of this complicated function, 1 over x to the second plus 7x plus 12. Whoa, that's a little complicated function. Or you want to take the integral 2x minus 5 over x to the third plus x to the second. We don't know how to take the integral of that complicated function. So the idea is you're going to find out the partial fractions of this complicated fraction, which is these are your partial fractions. You could be 2, it could be more than 3. So once you find out the partial fraction, then take the integral of the partial fraction. Maybe it's going to be better to solve the problem. So we call 3.4, the title is That's Why Partial Fractions Integral. Okay, so actually you guys already learned how to find out the partial fractions by following the 3 different cases. So sometimes the first step is you're going to look at the structure of the denominator. So x to the second plus 7x plus 12. You can have a factor of that expression, that is x plus 3 and x plus 4. Or if you have a denominator x to the second minus 7x plus 10, just find out the factor, 2 binomial factor. It'll be x minus 2, x minus 5. So once you look at the partial fraction, these are your partial fraction. And then x minus 2, x minus 5, they are not repeated. They are simply linear function. And then when you have non-repeated linear factor, this is what we call case 1. Sometimes when you find out the factors of the denominator, you might have a repeated factor like x times x, x to the third plus x to the second. When you take out the factor, it is going to be you have a common factor x second and then x plus 1. So x is a repeating. So the second case is a repeated linear factor, case 2. Okay. And then the last case is you might have, when you have a complicated function, look at the denominator, and then this is already factored form. They have a quadratic, and then it's not repeated. So the non-repeated irreducible quadratic factor, this is case 3. So you actually explored those 3 cases in terms of finding partial fractions in pre-calculus. We're simply taking the integral of those partial fractions in calculus 2. So it sounds like a little bit back and forth. So I will show you the example, and then we're gonna take a step-by-step work, okay? So remember, the language a little bit, the partial fractions could be more than 2. So any fraction can have a partial fractions, right? And then we call that process to find out the partial fraction is a decomposing work, okay? So I'm gonna show you all 3 cases, in a few seconds, but let me show you the example, the popular example to take the integral of the complicated function. So let's look at the example. Here we go. So in this example, I wanna take the integral, right? 1 over x to the second plus 7x plus 12. So we know that this is your denominator. And then there's no information from the integral table how to take the integral this kind of function. So we have to think about it. And one of the method is finding partial fractions. So step 1 is, right? You're gonna decompose the fraction. So we do have, and then you will be able to find out the partial fraction. So we're trying to find out the partial fraction, 1 over x to the second plus 7x plus 12 plus 12. So what I'm saying is 1 over x to the second plus 7x plus 12. It's a summation of 2 or more than 3, 2 or 3 partial fraction. We're gonna find out those partial fraction of 1 over x to the second plus 7x plus 12. So that's what I'm gonna do step 1. So the step 1 is you're gonna find out the factor. So x second plus 7x plus 12. You can find out the 2 binomial factor. So 1 is going to be plus 3 plus 4. So these are the binomial factor of the denominator. So therefore, we are going to take the integral, but let me ignore for a second, because I'm going to simplify the partial. I'm going to try to find out the partial fraction. So 1 over x to the second, 7x plus 12, that is going to be what? We have a 2 partial fractions. So 1 is going to be with the x plus 3 denominator. And then another second partial fraction has a denominator x plus 4. And then we don't know the information of the numerator. So I'm going to say a and b. So what does it make sense? So this is the partial fractions of 1 over x to the second plus 7x plus 12. I don't know the numerators yet. We're going to find out. Okay, so these are partial fractions, and let's find out the a and b. So to find out a and b, we used to have a common denominator. So for the first fraction, you're going to multiply x plus 4 top and bottom. And second fraction, you multiply x plus 3 top and bottom. So what happened is the first fraction will be a times x. You're going to do the distributive property, ax plus 4a, and then we have x plus 4, x plus 3. That's how you are adding the 2 fractions by finding the common denominator. And second fraction, bx plus 3b over same common denominator. So end up, you can adding all together because now you have a common denominator. So ax and bx, they are same family, right? Because ax plus bx, they are same family with the x. And then, as you see, 4a and 3b, they're going to be the same family, like term constant. So I can say ax plus bx, same family. 4a, 3b is going to be the same family. Are you following? So let me minimize a little bit. So now I can rewrite it. The denominator here, and then x I can combine, x plus b factor x, and then 4a plus the 3b. So what I'm saying is, this is going to be x family. This is going to be the constant family. And then this is going to be equal to, so I'm going to highlight this partial summation is going to be equal to this. They're going to be equal. So what does it mean? In the original equation, it's the numerator is equal to 1. So what that means is a plus b must be equal to 0 because they don't have x variable. The constant is going to be 1. So therefore, from there, what we got, a plus b should be 0. 4a plus 3b should be 1 because they are going to corresponding 1. So this is two system of equation in basic pre-calculus course. So you're going to solve for a and b. So here I'm going to multiply 3, 3, 3. And then you're going to solve for a and b. So subtract. So minus a equal to 0. Actually, I forgot 1 here. So it's going to be 1. A is going to be negative 1. So if a is 1, b equal to 0. So what I'm saying is now you can complete the partial fraction right there. So now we have a equal to negative 1, b equal to 0. So these are your two partial fraction, right? So therefore, 1 over x second plus 7x plus 12 equal to, plugging in negative 1a plus 0, which is, b is actually my mistake. B is what? If it's negative 1, b should be positive 1. So b is 1 over x plus 4. So we found out the two partial fraction. These are partial fractions of the 1 over x second plus 7x plus 12. So you found that we didn't know what the a and b, but we were able to find out. So now what happened? We are going to take the integral, right? So we are taking the integral. So instead of taking integral with this complicated, this is going to be much easier. So now you're going to take the integral of a partial fraction. So if I separate it, negative 1, I'm going to put it in the front. So x plus 3 dx plus integral 1 over x plus 4 dx. So according to a little bit of note, if you forgot, integral 1 over x is going to be ln x. So therefore, this one is going to be negative ln absolute value x plus 3. And then this is the second one is going to be ln absolute value x plus 4 and plus c. That's your answer. We just took the integral of that complicated fraction by finding partial fraction. So basically, you're not going to take the integral of this. You're going to take the integral of that partial fractions. Okay? So that's what we are doing in 3.4. The concept is very simple. Just you need to find out the partial fraction and take the integral. Does it make sense to you? So I hope this is not something new. We already learned somewhere in pre-calculus just long time ago, right? So let's take a look at the second example. Let me just bring that question. So this is the second one. So I'm going to make a space. So we have x plus, so let me change the question a little bit. This one should be actually not 1, 4. So let me just rewrite it. This is 4. So if I rewrite the question, We have x plus 4 over x plus 3 dx. Again, this is a little bit complicated. X plus 4 over x plus 3. This is not composition function. Well, it's a little bit complicated. So what we're going to do, what if we are finding the partial fraction of that? So you can think about it to find out the partial fraction. Okay. So by the way, the integral table, right, does not show us what the result. And then we are not going to use substitution. Nothing is going to work. So basically, we're going to find out the partial fraction because of the characteristic of this fraction. So integral, so I can think about it. X plus 4 is a little bit heavier than x plus 3. So maybe I can rewrite it. X plus 4 is the same as x plus 3 plus 1. And then bottom. And then what I'm trying to do, what if we are going to make a heart? So we can break them into this two fraction. Do you remember that? So if you have like a plus b over 3, it's the same as a 3 over a plus b over a over 3 plus b over 3. So therefore, this is going to be same as integral x plus 3 over x plus 3 dx plus, or I'm going to just separate it, plus 1 over x plus 3. We can separate it. So that means they're cancel 1 and then dx plus integral 1 over x plus dx. We know that this is going to be x. This is ln absolute value x plus 3. We can get the answer in shortcut. So there are many ways you can think about finding how to find out the partial fraction. So these are partial fraction. X plus 4 over x plus 3 has a two partial fraction, 1 plus 1 over x plus 3. So I literally take the integral of their partial fractions. So that's how you can do it. Are we okay with that? So we're gonna keep practicing like that because we have a variety of forms of the partial fractions. So let's think about slowly and slowly. Okay, so let me go down. Here we go. Okay, so now I want to same question. It's a fraction. I want to find out the partial fraction of it. So what are you guys gonna do? X second plus 4x plus 1. If the numerator is a little bit heavier, so which means larger than denominator when you plug in the same number, this one you can think about the heart breaking. you can think about like this, two different fractions. So let's think about it. I do know x second plus 4x plus 1. You can think about binomial factor. So let's say we have x plus 3. And then it's not going to be, it does not have a two binomial. So I'm going to modify a little bit. So x second plus 4x plus 1. If you do this, let's see what happens. X second, x, 3x inside and last, x second plus 4x plus 3. But we have to get 1. So why don't you subtract 2? Then it's going to be x second plus 4x plus 1, isn't it? So I can say this is equal to x plus 3. The numerator x second plus 4x plus 1 is the same as x plus 3 plus times x plus 1 minus 2 x plus 3 dx. So the purple, they're same information. Yeah. So that one was very, very something you need to think about. And then now you can separate it, this together and this together. So therefore, x plus 3, x plus 1 over x plus 3. And then we have negative 2 over x plus 3 dx. Dun, 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 dun. So they are going to be canceled. We have x plus 1 dx integral 2 x plus 3 dx. So what does it mean? X second plus 4x plus 1 over x plus 3 has a two partial fraction. X plus 1 minus 2 over x plus 3. So these are two partial fractions. We just found it. And then you can, if you take the integral, this is going to be x second over 2 plus x. This is going to be 2. And then absolute value x plus 3 plus c. So you can find out the result of the integral of this fraction. So we are utilizing finding a partial fraction. Okay. All right. We are getting better and better and better. Are you getting better? I hope so. So let's take a look at one more example like this. So when you have a simple factor. So let me go down slowly. Same thing. This purple is a little bit larger than denominator, so we can break them into two binomial and something. So let's look at that. X second, 3x plus 5. So you have x plus 1, so I'm going to have x plus 1. And then if I have x plus 2, we are getting close to x second plus 3x plus 5. But it's not going to be same. So let me see, x second, 2x inside 2. So x second plus 3x plus 2. I need 3 more to get 5. So we are adding 3. So what I'm saying is by doing this work, what happened? This is equal to integral x plus 1, x plus 2, plus 3 over same x plus 1. So these purples are same. We just found that. The reason why I'm doing this, because I want to have the same two fraction. We have a same denominator fraction, partial fraction. So therefore, we can separate it. X plus 1, x plus 2 over x plus 1. And we have a plus 3 over x plus 1 dx. Dun, 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 dun. They're going to cancel. So integral x plus 2 dx. Integral 3 over x plus 1 dx. So that means x second over 2 plus 2x. And you can bring 3 to the front. So 3, it's going to be ln absolute value x plus 1 because 1 over x plus 1. And then plus c. So that's your answer. Same thing. Okay. So the example 3 and 4, they were very similar question. Okay. So it's getting better and better. So this is the case where your numerator is a larger when you're plugging in the same number in numerator and denominator. So let's take a look at a little bit complicated fraction. Okay. So if you're ready, I'm going to go down slowly. Now your denominator is heavier, right? When you're plugging in the same number, denominator will be, complicated. So in this time, we're going to find out the factor. So x second plus 3x minus 4. Can I factor out? So in this time, x plus 4, right? X minus 1, exactly. So if you do x second, x or x minus 4, this is exactly same as x second plus 3x minus 8. So we don't need to add in nothing. So by doing that, now it is equal to, what happened? This is a denominator. So this means we don't know the numerator, but these are your two partial fractions denominator. So a over x plus 4 plus b over x minus 1. These are two partial fractions of x plus 5 over x second plus 3x minus 4. I don't know the numerator yet. That's something you're going to find out. So how would you find out the a and b? I'm going to multiply here x minus 1 top and bottom to the first fraction. You're going to multiply x plus 4 to the second fraction to find out a and b. So if you do, what happened? You're going to do the distributive property. So ax minus a over x minus 1, x plus 4, plus do the distributive property bx plus 4 b over x minus 1, x plus 4. So I can adding them. So let me just write here. So now this is going to be equal. What happened? Combining like term. Ax, bx, they're same family. And then negative a, 4b, they're constant, same family. So I can entire now. They have the same common denominator. So a plus b, they're same family, x. And then negative a plus 4b, they're constant family. Does it make sense? So this is a constant. And then this is the x family. So why? Why should I have to do that? Because I'm trying to find out what the a and b. So what happened when you look at that? This is x family. This is a number family, correct? So what does it mean by that? A plus b should be invisible 1 minus a plus 4b should be equal to 5. Right? So you're going to find out two system of equation to solve for a and b. A plus b equal to 1 minus a plus 4b equal to 5. So we're going to solve for a and b. 5 will be equal to 6. So b will be 60 over 5. And you're going to solve for a. A plus 6 over 5 equal to 1. A will be negative 1 over 5. So we have a and b. So this is your a. This is your b. So we're going to plug in back to your partial fraction. These are your partial fraction. So let me make a space. So we know, go back to the question. We have x plus 5 over x second 3x minus 4. We found out the two partial fraction, which is a over x plus 4, b over x minus 1, correct? So these are your two partial fraction. And then I'm going to plugging in a and b. So that means a is negative 1 over 5 over x plus 4. And then b is a 6 over 5 over x minus 1. I can bring the number in front of the integral. So negative 1 over 5 integral 1 over x plus 4 dx. 6 over 5 integral 1 over x minus 1 dx. So now this is going to be ln absolute value x plus 4. 6 over 5 ln x minus 1 plus c. There we go. We got the answer. So this is the case where your denominator can be factored without repeating. Okay, getting better and better and better. I like it. I like this type of question. So I'm going to keep practicing with you guys while you're watching video. You definitely write on everything on your notebook, right? So you can download our slide so that you can work with that. All right, so now I'm going to do the couple more practices. Here we go. Okay, similar type of question. So 3x plus 2 over, okay, look at the denominator. This is a complicated. So let's find out the factor. So x to the third minus x to the second 2x. I have a common denominator x everywhere. So 1x, then it is going to be second, x minus 2, correct? So if you do the distributive property, it go back to the same. Now I can factor x second minus x minus 2. So there is minus 2 and plus 1. What does it mean? These are your partial fractions. So it means integral a over x plus integral b over x minus 2 plus integral c over x plus 1. So these are your partial fraction denominator. Okay, so this is your first denominator, second. The order does not matter. So you're going to find out that. These are your partial fraction at a over x, b over x minus 2, c over x plus 1. And then we're going to take the integral at the end. So let's find out ABC. Let's find out the ABC. So what are you going to do? There should be dx at the end. So I'm going to find out the ABC. So find out the common denominator among those three, x minus 2, x plus 1. So if the common denominator is actually all together. So for the first fraction, you're going to multiply x plus 1, x minus 2, top and bottom, so that it's going to be all together. To the second fraction, you're going to multiply x times x plus 1, top and bottom. And the third fraction, you're going to multiply x times x minus 2, top and bottom. So if you do that, let's see what happened. So the first fraction, a times x plus 1, x minus 2 over x times x plus 1, x minus 2. Second fraction, b over, I'm going to omit the integral symbol for a second. So let's organize all the information first. b times x plus 1 over x minus 1, x plus 1, x minus 2, all same common denominator. cx, x minus 2, x plus 1, x minus 2. So now you can adding them up because we have all common denominator. So all common denominator, x plus 1, x minus 2. So you're going to do the distributive property. A, x second, x minus 2, b, x second, x, c, x second, 2x. And I'm going to keep going. Do the one more time of distributive property. So a, x second, ax, 2a, bx second plus bx, cx second, 2. I think I have a little bit of typo. Actually, we are right. So we have 2cx over x plus 1, and I do have x minus 2. Okay, so here, look at that. We have a common like term, x second family, and I do have x family, right? And I have what? Number family. So what does it mean? I'm going to combining like term. So it is going to be a plus b plus c, x second family, minus a plus b minus 2c, x family, and negative 2a, that's a constant family. So that is going to be over x plus 1, x minus 2. So this fraction is going to be equal to this. So now, when you look at the original one, there's no second power. So what does it mean? This is going to be 0. And then x, we have a 3. This is going to be 3. And then this is going to be 2. Yes, so we can say now, a plus b plus is equal to 0. Negative a plus b minus 2c equal to 3. And negative 2a equal to 2. So you have 3 system of equation to solve for ABC. So let's find out what the ABC was. So if you do, here, a will be negative 1. Okay, that's good. So you're gonna plugging in a -1 plus b plus c equal to 0. That means b plus c equal to 1. Here, if I plugging in -1, double negative change it to positive. So 1 plus b minus 2c equal to 3. So b minus 2c equal to 2. So we can work this two equation to solve for a and b, right? So if I bring back here, b plus c equal to 1, b minus 2c equal to 2. So you're going to subtract. So 3c equal to -1. We got c equal to -1/3. So therefore, b will be, if you're plugging in here, it's going to be b minus, what is that? B minus 1/3 equal to 1. B will be 4/3. So we have A, B, C everywhere. So now we know that these are your partial fraction. So I'm going to bring this. These are your partial fraction, right? So we can work there. So I'm going to rewrite that. So I'm going to minimize this one a little bit. So now we do have, let me copy this. So we have integral 3x plus 2 over x third minus x second minus 2x. And then I found out, enter. So these are your partial fractions. So let me get rid of this. So these are your partial fraction. So these are your partial fractions. So now you're going to plug in A, B, C, what we got. So the A, B, C. So integral -1/x dx, 4/3 x minus 2 dx, C, -1/3 over x plus 1 dx. So we can bring all the number of x, 4/3, 1/x minus 2, minus 1/3, 1/x plus 1 dx. So we got it. This is -ln x, 4/3 ln x minus 2, minus 1/3 ln x plus 1, plus a c at the end. Are we okay? So that's how you're going to solve, taking integral of the partial fraction. Okay, so I hope it's getting better and better and better. Okay, so are you okay so far? I'm going to do just 2 more examples. It's going to be fun, but I want you guys to make sure you're okay here so far. And I'm going to just write down a couple notes in the next page. Okay, so let me make a space here. Very important slide. I'm going to write tips for decomposing partial fractions. Okay, so we have 3 cases. So if you have, let's say this is the example. Okay, when you look at the denominator, you have simply have 2 binomial factors. So the factor of this, we know that this is x minus 3 times x plus 2. So this is non-repeated linear factor. X minus 3 is not repeated, x plus 2 is not repeated. So therefore, you can simply a over x minus 3 plus b over x plus 2. So this is the case 1 when your factor is not repeated and it's a linear factor. However, there's another case. What if I have a 1 over x minus 2 to the third? What is the factor of the denominator? Look at that. This is repeated, x minus 2 times, x minus 2 times, x minus 2. So this is we call repeated linear factor. So if you have this case, the partial fraction is going to be this. So each factor is going to be the denominator. So a over x minus 2, and then b, but then you keep increasing the exponent up to 3. So this is how you're set up the partial fraction form. Okay, so this is a repeated linear factor. Last case, let's say I have a 5x minus 1 over x to the third, x plus 3, x second plus 1. So first of all, you have a very mixed one. This is x times x times x. This is a repeated linear factor, but x second plus 1, what happened? This is a quadratic, not linear. This is quadratic, non-reducible factor. So if you have this one, watch me, what happened? Because of the x, a over x plus b over x to the second plus up to third time, because they're repeating 3 times. And then the second factor is this. And then it's going to be d over x plus 3. And then last one is special. If you have a quadratic, very important, quadratic non-reducible factor, okay, keep x second plus 1, but then you're going to reduce down. The numerator is going to be the reduced down form, ex plus f. It's not going to be just one constant. So we remember, this is increasing the x second power, right? So I'm going to highlight the same color. X second, x second, x to the third. And then second here. And then last one, quadratic. But then it's a special. You have to reduce down. Quadratic is a 2-dimensional. The reduced down dimensional is going to be 1 dimension. So ex plus f as a linear. So very, very important 3 cases. So once you got these 3 cases, finding partial fraction, it's going to be much, much simpler. Okay, so let me show you one of the complicated case. Okay, so are you ready? So let me show you that example. Here we go. So keep in mind those tips. So here is example 7. So I have x second plus 3x plus 1 over x second minus 4. So when you look at the denominator, let's find out the factor. What happened? This is x plus 2 and x minus 2. So you know that this is a non-repeated linear factor. And then also the numerator is complicated. Numerator is also complicated in this time. And then let me see, actually, this is a little bit challenging question. Let me actually divide it. So x second plus 3x plus 1, numerator divided by the denominator. So what happened is, you can find out just, 1, because 1 times x second minus 4 is going to be that. And then cancel, 3x bring down. 1 minus 4 is a negative 3. So what happened is, actually I have a negative 4 here. So let me get rid of this. We have negative 4 here, because right, 1 times x second minus 4 is x second minus 4. So x second minus 4, and then you subtract. So they're cancel, bring down 3x, 1 minus change it to positive. So what I'm saying is, if you remember, like 7 divided by 3, 2, and we have a remainder 1. So we call this as quotient. We call this as remainder. Do you remember? Long time ago. And this is we call divisor. So in order to, so there's a remainder in this fraction. So we can rewrite it. This is same as, we have quotient plus the remainder 3x plus 5 over divisor, right? That's how you write down the form. That's your partial fraction, kind of, so far. And now we found out this denominator is a non-repeated linear factor. So therefore, we have 1 dx and then 3x plus 5, x plus 2, x minus 2 dx. I'm going to find out the partial fraction of this. So it is going to be, so this is anyway x plus, you have a over x plus 2, b over x minus 2. These are the partial fraction form of that complicated fraction. You okay with that? So this is a little bit challenging question. Think about it. So let's find out the partial fraction a and b. So we're going to multiply here x minus 2. You're going to multiply x plus 2. So let's find out the partial fraction. So let me here. X plus integral x minus 2a over x plus 2, x minus 2 dx. And then plus bx plus 2b, and then x minus 2, x plus 2 dx. So we know we need to find out the combining like term. So x, you can ignore the integral for now, but anyway, it's all together. Same denominator. So ax plus bx, same family. Negative 2a plus 2b, same family. So what does it mean here? These are your partial fractions. So those I'm going to rewrite it. X, a plus bx minus 2a plus 2b over x plus 2, x minus 2 dx. So we know these are going to be same. 3x plus 5, 3. This is going to be 5, correct? So from there, a plus b equal to 3. This is going to be 5. 2b equal to 5. You can find out a and b, isn't it? So it's going to be 2a plus 2b if I multiply 2 everywhere. And then negative 2a, 2b, 5, adding them. Cancel. 4b will be 11. So b is going to 11 over 4. And then if you're plugging in, a will be 1 over 4. So we found out the partial fraction. There's x plus. So therefore, finally, x plus, we have all the partial fraction. So the partial fraction of it here. These are partial fractions. So I'm going to plugging in. Integral 1 over 4 over, what was it? X plus 2. And then integral 11 over 4 over x minus 2. So again, x plus, this is 1 over 4 ln x plus 2. 11 over 4 ln x minus 2 plus c. Woohoo, we got it. I know it's a little bit of work you can do. So this is, you need to start with the quotient and remainder because this is both heavier. So you can find out the factor top and bottom. So I found out the quotient plus the remainder. Then you're going to start to find out the partial fraction of the second fraction. Okay, so that's the step. The rest of step is the same to find out a and b. Okay, so this is a little bit challenging question. You can think about it. Okay, so though I have a rest of question, I'm not going to do everything. Just I'm going to find out the partial fraction form, and then taking integral, it's not that complicated. So let's take a look at it. Okay. All right, here we go. So look at that. Denominator. So you know, x minus 2, it's everything is already factored. X minus 2 is repeated, x plus 3 is not repeated. So we have repeated linear factors. So these are all your denominator. So what happened? A over x minus 2, right? Plus b over repeated, you're gonna up to repeated exponent. C is x plus 3. So then you're gonna solve the rest of thing, find out the common denominator, right? You're gonna multiply here x plus 3, x minus 2, top and bottom. Here you're gonna multiply x plus 3. Here you're gonna multiply x minus 2 to the second. Then you're gonna find out the ABC, and you can find out the partial fraction fully, then take the integral. Try. So I'm just helping you to set up the partial fraction form so far. So likewise, look at that. Same thing. What happened? 2x minus 1 is repeated. So what happened when you're setting up the partial fraction? A over 2x minus 1, right? Plus b over 2x minus 1 to the second, correct? C over x minus 1. So that's your partial fraction form, and you're going to find out the ABC. For the first fraction, you're going to multiply 2x minus 1 times x minus 1, top and bottom, to find out the common denominator. And second fraction, you're going to multiply x minus 1. Second fraction, you're going to multiply 2x minus 1 to the second, and then you're going to find out ABC, then take the integral at the end. Try. But the important part is, do you know how to set up the partial fraction form? Okay, so it should be getting better and better. Nothing is special, okay? I'm gonna do the bottom one. Let's set up the partial fraction form first, okay? Just practice that one last. Okay, example 10. Okay, let's do this one. So what happened? Look at that. This is what? When you find out the factor, x second plus 1. This is what? This is quadratic non-reducible factor. So if you set it up, x is it's a fine, it's just a non-repeated. So a over x plus x second plus 1. But then what happened? This is a quadratic. You're going to reduce down bx plus c as a linear. Does it make sense? This is how you set up the partial fraction. Now you're going to do the work. So let's do this work. So the first fraction, I'm going to multiply x second plus 1. Second fraction, I'm multiplying x. So this is going to be ax second, a over x times x second plus 1. Second fraction, I'm multiplying x everywhere. So bx second, cx over x second plus 1. So now you can combine them. X second plus 1, a plus b, they're same family, x second family, right? And then number family, b for number family, we have x family, and then constant, correct? X second, x, and constant, correct? So when you look at the numerator, we don't have x second, so this is going to be 0, correct? C is going to be 1. And then a is going to be 1 automatically. So a plus b equal to 0. C is 1, a is 1. So b should be -1. So you can fill out the partial fraction right now. So therefore, you can say now what happened? A is 1 over x. B is a -1x, -1 times x, and plus 1 over x second plus 1. This is your partial fraction. And we're simply taking the integral of the partial fraction. So almost done. So we're going to take the integral. So then integral 1 over x dx, integral negative x plus 1 over x second plus 1 dx. This guy will be ln absolute value x. Oh, how do I do the second fraction? So this one, same thing. I'm going to separate it. So that means integral negative x over x second plus 1, right? And then integral 1 over x second plus 1 dx. This is a little bit of work. We're going to think about it. How are you going to take the integral of that? So this one, we could think about the u substitution. So u equal to x second plus 1. Du over dx is a 2x. Du 2x times a dx. So you guys find out what the dx, du over 2x is a dx. So actually this means integral negative, right? But we need to find out here negative x times the dx. So before actually I'm going to do this, I'm going to modify this. I need to find out x times the dx. So from here, I'm going to divide it by 2. So du over 2 is x times the dx. And then you can multiply negative, right, on both of sides. So negative du over 2, that's a negative x dx. So we can rewrite it. So let me just minimize it. So there, integral 1 over u, and then x, negative x dx, it's a negative 1 over 2 du, correct? So that means negative 1 over 2 ln u. Ooh, got it. And you can go back to the x variable ln u was x second plus 1. So that's the second part answer. So we have still ln absolute value x. And then this one, what do you guys do? Go to integral table. This is the, we learned this one in chapter, I think 3.1, 3.2. This is the same as tangent invert x. So plus tangent invert x. And then plus c. Whew, this is a challenging question as well. Think about it. We got it, but we got it, right? So think about it. There's a multiple skills you need. I'm going to highlight it. Are we okay? So please, please think about it. This is one of the question, that you need to know a lot of skills, but, pretty much finding, as long as you're able to find out the partial fraction, then take the integral. That's some, you learn a lot of skills, so you can utilize it. Awesome. Okay. All right. So I'm going to do just a couple more. Almost done. Hang in there. Almost done. I'm not going to do everything. Let's just set it up. So look at the denominator. This is repeated. X second plus 1. Nothing repeated, but I see quadratic. So it'll be a over x, right? And then plus x second plus 1. But then this is a quadratic. So don't forget that. Reduce bx plus c. Then you're going to do the rest of work. Try. It's the same question. 11 and 10 are very similar. Okay, very similar. So you can practice one more time. Okay, the last one, many people like, what if I have a super complicated? Ooh, this is a super complicated. So we know that this is x times x times x. This is x second plus 1. Multiply twice, and we have x minus 3. So basically, you're going to have 1, 2, 3, 4, 5, 6 partial fraction. So the number of the factor is equal to the number of the fraction. So I'm going to write it. Number of factors of denominator equal to number of partial fraction. Got it? So what happened? I'm not going to solve it, but I just find out the partial fraction form. So these are repeated. So if you have a repeated, we know what's happening. And then this is nothing. So what happened? Equal to a over x, b over x second. You're going to keep increasing. And then x second plus 1 over what? This is a quadratic. So don't forget that. I'm going to write it here. dx plus e form, linear. Same thing. Here, you're going to increasing x second plus 1 up to second times. And then reduce fx plus g, correct? And then x minus 3 is linear, just h. So many people confused. This is a quadratic and repeated up to 2, but then you have to reduce down the numerator. X second, x3, they're repeated. This is not repeated. Okay, so that's your partial fraction form. I'm not going to ask you to solve it to find out A, B, C, D, E, F, G, but as long as you have complicated function, look at my tips, and then you can set up the partial fraction form. Okay, so that's all about 3.4. Yay, we finished that. If you need more practice, there are embedded video you can watch in our quiz. Every quiz has embedded video. So you can study as well. You can build up a better concept. We do have a textbook, is also great resources. So there are a bunch of, practices you need. So my lecture is all the extract, concept you can practice with me. And then please complete all the quizzes. And then if you have any question, come to discussion board and let's work together. Okay. Thank you, everyone. I will stop here. I will see you in the next video. Bye-bye.